Consider a mixture of equal masses of H2, N2, and Cl2 at 1 atmosphere and room temperature. Which gas is exerting the most pressure? Which gas has the highest average kinetic energy? Which gas has the greatest average speed, also called the RMS speed? And which gas would effuse the slowest through a pinhole? Part A. Which gas is exerting the most pressure? So to answer this question, it is key to understand that having equal masses of gases in the mixture does not mean you have equal moles. Moles is mass over molar mass, and so the substance that has the smallest molar mass, the gas with the smallest molar mass, is going to have the most moles, since the mass of each gas is the same. So, since we have equal masses of each gas, the gas with the lowest molar mass will have the most moles present. And Avogadro's law says that moles is directly proportional to volume, or directly proportional to pressure in this case, which means that the one with the most moles is going to collide with the walls the most, which is going to produce the highest partial pressure. And so the answer is H2, since it has the lowest molar mass. Part B asks, which gas has the highest average kinetic energy? The average kinetic energy of a gas is directly proportional to its absolute temperature, its Kelvin temperature. So this is a relatively simple question to answer. Since all three gases in the mixture are at the same temperature, they all have the same average kinetic energy. That's it. That's all there is to it. Part C, which gas has the greatest average speed? Average speed is also called the RMS speed, which stands for the root mean square speed. You can calculate it using this equation. This equation is not on the AP exam. It's not something you have to know how to use. It's just something that you have to understand. So looking at this equation, the root mean squared speed is equal to the square root of 3 times RT divided by molar mass. Well, if we're comparing gases that are at the same temperature, then the top of this fraction here, 3RT, is the same for all three gases. And so the average speed of the gas really only depends on its molar mass, assuming that the temperatures are the same. And so we can actually simplify this expression to just say that the RMS speed of a gas is directly proportional to 1 over the square of its molar mass. And what this really means, if you boil it down to what you actually have to understand for the exam, is that if you have gases that are at the same temperature, the lighter gases have higher average speeds. And so if that's the case, then the lightest gas is going to be moving the fastest on average. And so that gas in this case is hydrogen. The last part, part D, which gas would effuse the slowest through a pinhole? So when a gas escapes the container through a small opening, we call that effusion. And effusion can be mathematically represented by what's called Graham's law of effusion, which is this equation right here. This is another equation that you don't have to know. We're not going to use this equation mathematically. But what this shows is that the rate of effusion of a gas is inversely proportional to the square root of its molar mass. So the most important thing, the thing you really need to understand, is that heavier gases will effuse at a slower rate. The higher the mass, the slower the rate of effusion, and vice versa. And this is just directly related to its average speed. Heavier molecules are moving slower on average at the same temperature, which means that they will effuse slower. They will leave the container at a slower rate. It's really that simple. And so in this case, the heaviest gas is Cl2, and so that is going to be effusing the slowest through a pinhole.